these are the company tags, and next is the topic tags, right? Cool. Let's see what's the question. An array of intervals where intervals I start and I merge all overlapping intervals and return an array of the non-overlapping intervals that covers all the intervals in the input. All right. Great. What do we need to do here? For example, let's see. There's 1, 3, 2, 6, 8, 10, 15, 18. You check these intervals. These are basically overlapping. We merge it and make it 1, 6. And then we go ahead and check 8, 10, 15, 18. All right. Where this will become 1, 5. All right. So it's basically similar to insert interval, the previous question that I saw out of the list. Kind of similar, basically. All right. Since we need to merge the intervals, merge the overlapping intervals, so then first thing we need to have the intervals in a sorted order, right? Next will be alright, well, no, how do you do that? Let's say I start traversing 1, 3. I'm over here, 1 is this, 3 is this, then I go ahead. Start is this, right? So it's kind of like I plus 1 start is what? Less than equal to and this is what I can see over here. This will be the condition where, alright, yeah. So since we are making overlapping intervals, so is it possible like this was 1, 3, 2, 6. Next becomes what? Let's say next becomes 5 to 8. Let's say 5 to 7. So we'll also need to include that interval. So if that was something like, basically it was something like this. 1, 6. Then I have, sorry, my bad. 1, 3, 2, 6. Then we have something like 5, 7. Then we have 8, 10. Then we have, let's say, 15, 18. Over here, what will happen is these 3 intervals will be merged, right? So how will these be merged? I start traversing. This is less than, this is greater than this. So the new interval becomes something like 1 to 6. Right. Next, I go here. This less than this. Yeah. So what we can do is Let's try this approach. First things first, we need to sort it, right? Okay, how do you sort an array? Let me try and remember how can I sort this array. I think I have something like arrays dot sort. Then I pass my comparator, which is AB. This will be in ascending order of start. So it will be like A0, B0, start.
Come on.
Right, I'm here. Right, what do I need to do? Current int is greater than. Basically keep updating the end, right? Start will remain the same. Over here also start will remain the same. We just keep updating the end. Else, if this is not the case, you have to check equal to case also now, because if this was, let's say, 6 to 7, yeah, this is the correct condition. Otherwise, what we'll do is Oh, we need to pass dimensions to at least one of them. All right. Uh, complexity is definitely in log n time complexity because we're sorting it and then we are using a single traversal. Right, right. So I think, is there any other optimal solution to this? Let's see. Oh, there is a better approach also. Wow, that's nice.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve merge intervals. We are given an array of intervals with a start and an end value. So an interval is a start and end value. You can think of it like a class or a meeting or some kind of time period or whatever. And for each of these intervals, we want to take all the overlapping intervals and then merge them. And then we're going to have a new output array of intervals. And since we merged the overlapping intervals, the result is going to be non-overlapping. So in this case, we see we have interval 1, 3 and 2, 6. So these two are overlapping. We can merge them into one interval 1, 6. The remaining two intervals are non-overlapping, so they do not get merged. And then we see that the output has 3 intervals, one that we had to merge to get, and then the 2 original. And this second example just basically clarifies that if we have one interval 1, 4 and a second interval 4, 5, now these aren't technically overlapping in a sense, right? Like we have 1 to 4 and 4 to 5. So they clarify that these two actually do count as overlapping. So what's a good and efficient way to solve this problem? Let's say we're given the exact same 4 intervals that we were given in the original example, but notice this time they're out of order. This one is 1, 3, this one is 8, 10, this is 2, 6. It was originally over here, right? They had given the input to us in sorted order, right? So that's kind of a hint that it might be helpful for us to keep our intervals in sorted order. But what's a good way to kind of visualize what's actually going on with these intervals? These numbers are pretty descriptive, but it's better to have a picture to look at. So I'm going to draw a number line and we're going to start at 0 because they clarify for us in the problem that any interval is not going to start at like a negative value, so we can start at 0. So let's just start putting these intervals into our number line and see what happens. So we have 1, 3, so I'm going to have a line going from 1 to 3, which is over here. So this interval is length 2. We'll have an interval going from 8 to 10, another interval of length 2. We'll have an interval from 15 to 18, and the last interval is from 2 to 6. So notice this time we actually do have an overlapping interval, 2 to 6. So I'm going to draw it above. So I'm going to draw it where it's obvious that we have two intervals that are overlapping. Now, when you actually draw out the number line, it kind of becomes obvious that it would be very helpful for us to take these intervals and sort them based on the start value. We don't care so much about the end value because we want to go through our number line starting at the beginning, starting at the start value, going to the next start value, going to the next start value, and then continuing that, because this allows us to detect. So for example, we look at this interval first. We know it goes from 1 to 3. Next, we look at the second interval, and it goes, if it does, are a lot normally, or we can just take interval, sort, and what's
That's the most common solution that the interviews will ask generally. So yeah, that's the only thing that's expected. So cool. I think the market is done. And do we need anything else? Like, do we need to mark anything else over here? No overlapping intervals. Give me an array of intervals, right? Okay, I think. Return the minimum number of intervals we need to remove to make the rest of intervals non-overlapping. Okay. So over here we need to remove what? Minimum number of intervals that we need to remove, right? Alright, so it is saying the only overlapping interval over here is 1, 3 because. Alright, so we're only considering it overlapping if. Alright, so these two are not overlapping because the end and start is basically equal, so we don't consider it overlapping, right? Yeah. Next thing over here, 1, 2, 1, 2, 1, 2. Most probably it will be like array sorting. Yeah. Array sorting. Oh. And interval. Yeah. That's nice. Now I think we can focus on the problem now. Huh. What do we have here? 1, 2, 2, 3. We need to basically find the overlapping intervals. That is what I need to remove, right? So for example, if I consider this, if I consider this, the sorted version would become something like this. It will become what? It will become something like this. So over here, if I see, this is overlapping with this and this, right? these are the overlapping intervals over here. We need to find out the minimum number of intervals that we need to remove in order to make it non-overlapping. So yeah, ideally we can remove this 1 to 3, or another option will be to remove these two intervals. All right, so either these or these, either these two or this one alone. Over here we need minimum, so we'll remove 1, 3, right? That's what we need to do in the question. All right. Let's see what else. Oh, valid order. We're not solving this one. Let's see what else we can get from this question. All right. Minimum number of intervals. How do we do that? Sort the intervals. That's what we do. It's like I keep a count for every single interval. It's like basically I count for every single interval with how many intervals is that overlapping, right? And what else? So do like I find the overlapping intervals first. Basically, what we can do is, all right. Find the overlapping intervals. For example, over here it is this 1, 3 for this, and it is overlapping with 1, 2, and 2, 3. What do we do after finding the overlapping intervals? What if? What is the brute force? Let's think about brute force first. I check for every single interval with which interval is it overlapping. And then what? Uh, 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 uh. How do we do this? How do we do this? Let's solve it for an example. On my notebook, I'll solve it on notebook with an example. I sort it. Let's say it becomes what? 1, 2, 1, 3. And then it becomes 2, 3. Then it becomes 3, 4. Right, I sorted it. This is the sorted order. After that, I start traversing every single interval. And basically, if the previous interval is 1, that is ending is greater than if previous interval का ending is greater than end is greater than current का start. Yeah, then definitely it's an overlapping interval. That's for sure. So what do? We update the what? Uh, okay, we have an option over here to remove either 1, 2 or 1, 3. What do we remove? We're removing 1, 3. Why? Is it because this is covering more interval gap? Alright, so okay. For this example, this makes sense. This makes sense actually. We need to do this because we need to minimize the size of current interval in order to reduce the possibilities of overlapping intervals. Right, so that's the reason we are removing 1, 3 over here instead of 1, 2. Then since we have 1, 2, we check with this and it doesn't overlap anymore. So it's more like arrays.sort intervals and you sort using the same comparator again, which is A0 minus B0. This means sort the intervals in ascending order of starting point. Next thing, we need to traverse the intervals, right? And we need to check current with previous interval, the current interval with our previous interval. For int I1, I is alright. Previous becomes intervals of I minus 1. If current का start is what? It is less than previous end. If this is the case, then what do? We remove our current interval, right? So we start does not affect us, to be honest. Start of the current interval doesn't affect us. We are only comparing it at the start with the basically start of previous interval doesn't affect us. The only thing that affects us right now is end of previous interval, right? So what we can do is we can basically do current of, basically we are updating current ka start, current ka end with current of 1, previous of 1, and this should work ideally, I think. Compile error intervals I minus 1. Oh, got it. Let's see if this works. Yep, it worked. And let me check the solution. If this is the most optimal solution that we can get or not. Oh, it has been done with the recursion also. What's the recursive solution over here? We sort the intervals and you do a DFS on it. If it is at the end, you return 0. Otherwise, you compare it with previous. Alright, and now previous becomes what? Okay, he's basically doing the same thing in recursive function. It's just that we are using -1 because it is basically used for 0 index, right? Next thing is he is checking if previous ka 1 is less than current ka start. Yeah, then he's updating his res to res 1 plus DFS intervals. All right, got it. Then he's just be memorizing the solution. Next is bottom up. Bottom up is what? Great. Let's see the video once. I want to see how he.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem non-overlapping intervals, and this is actually a problem from the blind 75 list of questions that we've been working on. And we've actually been tracking that list of questions on this spreadsheet. You can see that I do have a video solution on the left side over here for pretty much every single problem in this list, except for a couple that we haven't gotten to yet. So today we will be doing the last interval problem in this list. You can see I solved the other interval-related problems already. There's about like 70 people viewing it right now, so I hope that you guys are finding it helpful. And you can see conveniently I made a YouTube playlist for all of the blind 75 solutions linked to that will be in the description as well if you do want to take a look. So now let's continue with the video. So this problem is definitely like most interval problems in that if you've solved other interval problems before, this one shouldn't be too difficult. But if you're new to interval problems, this one is kind of challenging. So we're given an array of intervals where each interval has a start value and an end value, and we want to return the minimum number of intervals that we have to remove from the list to make sure that the rest of the intervals are non-overlapping. So first question you should ask is, what exactly is a overlapping interval? Well, assuming an interval looks something like this, right? It has some start value, maybe the start value is 1 and the end value is 2, right? Maybe we have another interval that starts at 3 and goes all the way to 4. So definitely these two intervals are not overlapping. But what if we had the interval starting over here? Maybe the end point is 3, but the starting point is maybe 1.5, right? Obviously, in this case, these two intervals are overlapping, right? You can see, right over here, this is the region that they're overlapping at. But the edge case comes when we have a interval, let's say, like this one, that's going maybe starting from 2 and going all the way to 3. Are these intervals overlapping? Technically, this point at position 2 is overlapping, but technically these intervals are not considered overlapping, right? So if they have the same edge point, they do not count as overlapping. This edge case is very important to understand to solve this problem. Okay, so let's take a look at the first example, actually. So you can see I've drawn a few of the intervals, and you can see so far these three are not overlapping, right? But we're about to insert the last and fourth interval, 1, 3. So it starts at 1 and goes all the way until 3. So now you can see that they are overlapping with the introduction of this interval. And things become really simple when you draw a picture, which is why I always recommend drawing a picture for complicated problems. So now we want to eliminate intervals. We want to eliminate the minimum number. It's obvious that we can just remove a single interval, this one that we just inserted, to make the rest non-overlapping. But of course, that's not the only way we could do it. We could instead remove this interval and remove this interval. So instead, we'd remove two intervals. That's clearly not the solution, but there are multiple ways to do it, which is why writing the algorithm for this problem can be kind of tricky. One definitely possible way to do this problem is brute force it, right? Go through every single combination, right? For every single interval, we can choose to remove this interval or to keep this interval. And if we have two choices for every single interval inside the list of intervals, then the time complexity to check every single possibility is going to be 2 times 2 times 2, basically 2 to the power of n, where n is the size of the input. So that's obviously not very efficient, but can we do better? And we definitely can, and it takes a greedy approach to solve this problem. When we're actually given this list of intervals, the ordering of them could be pretty random, right? But what you can see when we actually draw the picture, why would we want to go through these intervals in a random order? Why would we want to look at this one, then look at this one, then this one, yeah, right? Like in just a completely random order. When you look at it this way, it kind of makes sense to want to go left to right, right? To see, okay, here are they overlapping, here are they overlapping, etc., etc. And the easiest way to do that is to iterate through them in some kind of sorted order. You can probably do it sorted by the starting point or sorted by the ending point. I'm just going to stick with sorted by the starting point just because it's a little bit simpler for me, but I know that it works in both ways for this problem at least. So when we iterate through these in sorted order, first we're going to compare these two intervals, right? We want to compare adjacent pairs of intervals, right? And let's actually ignore this example for just a second. Suppose we had just two intervals, right? One interval like this and one interval like this. Okay, they're in sorted order, right? And we're comparing adjacent pairs. So we're going to look at this one and look at this one. How do we know if they are overlapping? Well, if they're sorted by the starting point, we know that either they both have the exact same starting point or the second one has a starting point that's after the first one's starting point, and that's the case here. But again, how do we know if they're overlapping or not? Well, the easiest way to check is they're not overlapping if this one starts after this one ends, right? If the second one starts after the first one ends, then they're definitely not overlapping. But on the other hand, if the second one starts before the first one ends, then they're definitely overlapping, right? You can see that this is the point that they're overlapping at. Okay, so does that cover all of the cases? Well, there's one more case. Technically, that's slightly different. What if, the first one is really long and the second one starts here, right? So it does come after this one, but it ends before the first one ends. This is a slightly different edge case. Again, they are overlapping. We can detect that with the same condition. This one starts before this one ends. So yes, they're overlapping. But now suppose we had a third interval that comes next. Remember, we are traversing these in sorted order. So first we're going to compare this one is first, this one is second. So then we're going to compare these two together. Next, are we going to be looking at this one and this one? In this case, yes. Because remember, if these two are overlapping, we don't have to remove both of them. We only have to remove one of them. So the choice is, are we going to remove this one or are we going to remove this one? Well, which one do you think we would rather remove? Would we want to remove the one that ends first or the one that ends second? Of course, we'd want to remove the one that ends first because then there's less of a chance that it's going to overlap with the following intervals that come after. And remember, we want to minimize the number of intervals that we have to delete. In this example, with these three intervals, it doesn't matter. We could remove this one or remove this one. But let's look at another example. What if the third interval was like this, right? It's overlapping with this one. Then it becomes pretty obvious. We would want to remove this bottom interval rather than this top interval. And it depends on which one of these ends first. So that's how we're going to decide which one to remove. And just to look at a third example, so what if they were overlapping like this, right? Of course, we're going to first compare these two intervals. Okay, yes, they're overlapping, and we can detect that because this one starts before this one ends. So now we have a choice. Do we remove this one or do we remove this one? Again, we're removing the one that ends first. So we're going to remove this one, and you can see exactly why, because now these two do not overlap. But what if instead we decided to remove this one? Well, we removed it, but it didn't help us because these two are still overlapping. We want to minimize that. So basically, I just explained to you the exact algorithm that.
Yeah, I guess we did the correct one. This was the perfect solution that we just came up with. So yeah, I think works like a charm. All right, let's do this question. What? These are locked. Awesome. These are locked. So we'll be solving it on Leetcode's platform itself. Cool. I have solved this. Cool. Given an array of meeting time interval objects consisting of, let me simply copy this. We have this meeting room description. Alrighty. There you go. The drop-in tags, company tags is Amazon, Google. Topic tabs becomes array. What else? It will be interval for sure. Alright. I know elite code is not opening, but cool. That's fine. No worries. Given an array of meeting time interval objects consisting of start and end times, determine if a person can attend all the meetings to the schedule without any conflicts. Oh, that's an easy one. We just need to identify if there's any overlapping interval or not. Not a big deal, right? Cool. So it is 03510. Do we need to sort it? Is it given in a sorted order? Nope, it is not. Cool. Average dot sort intervals AB. If alright, what do we need? Need to identify what? Cool. Int I starts from one. I is intervals dot length I plus plus. This would work. What? Average dot sort intervals. Oh, it's a list. Got it. Collections dot sort and p dot get 0. Collections dot sort Java. How do we do that? Let me check. I need it with a comparator. Yeah, there we go. Seriously, I don't need this. I need it using a comparator. Where is it? Where is it? All right. Okay, where is it? It is implementing a comparator, right? Oh man, I never thought I would be stuck in this. All right, it will be like what? It should be collection dot sort. Then you sort intervals. Comparator. You basically creating a comparator, right? Sort by here is the comparator. It will be something like comparator. Uh, this thing comparing int. I think this is one of the things. I think this should work. Oh, wait a second. It is start. Oh, oh, wait a second. Wait a second. The class? Seriously? Great. Then we can simply do a dot start. A dot start, and alright, here you do intervals dot get dot end, and this becomes dot start, and the third becomes, I guess, right, intervals. Okay, here it will be size dot get. Okay, I didn't see this. Awesome, this should work, I guess. Collection resort here. Oh, didn't add a semicolon. Yeah, this is working fine. Cool. I guess let's also solve this meeting rooms too. Minimum number of rooms. This is the same again. It's just you need to find the number of intervals, right? So for example, it is merging intervals, number of merging intervals basically. This is 0 to 40. Then you have 5 to 10, 15 to 20. 0 to 40 is merging with this. Then it is also merging with this. Awesome. Really need to calculate what. Wait, give me a moment, I'll be back in a minute. All right, I'm back. Cool. Let's see. What do we need to do over here? Let's open Obsidian first, and I'll be creating a new one. There's meeting rooms too. Let's see the company tags for once. And let me check the company tags. Over here it will be, yeah, there we go. Cool. This is the last question for today. And let's see if we can solve it or not. In an array of meeting time and double objects consisting, yeah, and the minimum number of days required to schedule all the meetings without any conflicts. Again, first of all, sort the intervals. Again, one of the common step in every single interval problem is to sort the intervals, because we need to check for overlapping intervals. So this is the most obvious step in every single interval problem. That's the pattern as of now that I observed. So yeah, let's see the next one. Given an array of, okay, we have 0 to 45 to 10, 15 to 20 over here. We need 2 days it is saying, right? 0 to 40 will be on day 1, and 5 to 10 and 15 to 20 will be on day 2, right? Okay, this is not considered as a conflict. Got it. So what do we need to do here? What are we basically checking out over here? See, 1 day is obvious that at minimum we'll be needing 1 day at least, right? Okay, if intervals dot length. Actually, so if it's 0, it returns 0. If it's 1, it returns 1. That's the base case over here. Alright, next thing is you're checking for 0 to 45 to 10. You basically do a sort on this, right? Which is what? Do we need to sort? Do we need to sort? Do we need to sort? Let's come to it later. Let's come to the rest of code later actually. Let's first build the algorithm. What do we need next? We have 0 to 40, 5 to 10, 15 to 20. Alright, let me try my code first, which I'm thinking. I want to see if it works. It be a basic sort, of course. And say it is smaller, you do this, and current dot end becomes what? Not current dot end, but it becomes like 20 to update this. We're not checking about this, right? Do I need to really update it? I don't think so. I don't think so. Let's see if this works. Okay, it failed for this test case. Awesome. It is 15263748559. What happened over here? 15. Yeah. Then 26 happened. Right. Of course, it went into another day. Then 37 happened. Four, 8, 5, 9. Okay, so it started from here. It is overlapping. This is overlapping. This is overlapping. Okay, all right. This didn't work out the way expected, right? to copy this, use the stitch case, and let's see if it runs perfectly or not. Does it run? It does run. Okay, now it failed for the stitch case. Awesome. Great. What's happening? 0 to 10, 1 to 3, 2 to 6. Alright, let me just write it over here. It sounds like what? Becomes okay, 0 to 10. I want to write one more thing. Okay, it is 0 to 10, then 1 to 3, 2 to 6. This is all in sorted order, right? Yeah. Okay, got it. Basically, it's not considering about days. Like, even if, uh, let's say we move it to another day, the current algorithm doesn't know that we have moved it to another day. It's still considering that, okay, that these both of these meetings are happening on the same day, and hence we are facing the wrong answer issue over here. All right, so that's the current issue with the algorithm. We need to change it. How do we change it? Let me do one thing. Let's see what we can do over here then. We have 0 to 10, 1 to 3, 2 to 6, 5 to 8, 7 to 12. One thing we need is we need to find maximum number of, that is for sure, we need to find maximum number of overlapping intervals on the same day. If all of these meetings were happening on the same day, how would you identify that which meeting is overlapping with another? Right. For example, these are overlapping with this 2, 6, 5, 8 up to 7, 12. These meetings are basically overlapping with this, so these cannot happen on the same day, right? So we'll have to move it, these meetings, to another day for now. Then comes these meetings. These will be overlapping over here, and this will be overlapping, and this will be overlapping. Yeah. So we'll be moving these to another day, right? That is something we need to figure out. And how do we do that? Is a question. What if I make an array of start times? Like it will be something like start times will be 0, 1, and 2, 5, 7, 11. Alright, let's do it with a smaller test case actually. Let me just use it. Alright, let's do one thing. For example, I create an array of start times. It becomes 0, 5, and 15. End times are 40. Sorry, so let's do it in sorted order. It is 0, 10, 20, and 40. Right. Can we do something with this information now? It's a question itself. We have 0 to 10, 5 to 20, 15 to 40. We sort it. Right. And we check if Alright, let me check the solution actually. Okay, what is this? What are these solutions? One is minimum heap, sweep line algorithm, and login. 2 pointers and login. Greedy is again in login. If both are equal, what will you do? You will sort it based on end time. Otherwise, do it based on this. Got it. What is the min heap approach over here? Does you sort it based on start time? Yeah. Then you create a minimum heap. And if it is empty and the peak is less than equal to interval dot start, you poll it. It was the solution actually.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve meeting rooms 2. And just like meeting rooms 1, we're going to solve this problem on the website called Leetcode because this is a premium Leetcode problem. So if you want to be able to solve it for free, you can use leetcode.com. So it's pretty similar to meeting rooms 1. We are given a list of meeting times. Each meeting time is an object and it has two variables. It has a start time and it has an end time. And the end time is always going to come after the start time. That's pretty intuitive. And we want to know what's the minimum number of conference rooms required for all of these meetings. Now what they actually mean by conference rooms is basically what is the maximum number of overlapping meetings at any given point in time. So for example, in this input, we have a meeting that starts at 0, ends at 30, another meeting that starts at 5, ends at 10, and then another meeting that starts at 15 and ends at 20. And we would need 2 meeting rooms for this problem because we are going to have 2 overlapping meetings. So if we had one room where the 0 to 30 meeting is going on, the 5 to 10 meeting is basically going to be going on during the same time as this one. So we're going to need a second meeting room for this. And we also have another meeting 15 to 20. Now it doesn't overlap with this one, so technically they can be a part of the same meeting room. Now we don't actually need to determine what goes in each meeting room. We just have to know what's the maximum number of overlapping meetings at any given point in time. In this case, that happens to be 2. We are going to be required to sort the input array which is going to take n log n time complexity. So this is going to be the time complexity of the algorithm. The memory complexity is going to be big O of n. I'm going to show you how to do the solution. Now, if you just stare at this, like the problem statement, and just look at these numbers, it's going to be difficult to come up with how to code the solution. But as you guys know, I like to draw pictures. And when you look at the picture, it actually becomes pretty easy to figure out how to solve this problem. So let's do that. So this is kind of how we can visualize those meetings, right? These are the exact same meetings that we were given in that first example. We have one meeting going from 0 to 30, another meeting going from 5 to 10, and another meeting going from 15 to 20. Now, if we just go from left to right, we're going to see, okay, well, this is the first meeting that starts, right? It starts at time 0. And if we just keep going, now we see what's the next point on our grid, right? Well, there's another meeting, and this is not an end time. This is not, the first meeting isn't ending. There just happens to be another meeting that's starting. So another meeting just started at time 5. So what does that tell us? That tells us 2 meetings have started so far, but nothing has ended, right? There's no meeting that's ended yet. So at this point in time, we're going to have 2 meetings going on at the same amount of time. So what we're going to be maintaining is a variable count, which tells us at any given point in time, what is the number of meetings going on? And right now our count is 2, and we're going to end up returning whatever the max value this happened to be. So what's the next point on our grid? We visited this one, we visited this one. Now we're looking at this one, right? Okay, at time 10, there's an end point. This is not a starting value. This is a starting value. This is an ending value. So what does that tell us? That tells us a meeting has just ended. So what are we going to do with our count? We knew we had 2 meetings going on at the same time over here, but now after this point, we're only going to have 1 meeting going on, right? Like look at the picture. There's only 1 meeting going on, and it's this first one, right? 0 to 30. So we're going to set the number of meetings going on to 1. Now we're going to look at the next point in order. Now it happens to be a start time. So another meeting just started at time 15, right? So once again, there are 2 meetings going on, right? At this point, there's 2 meetings going on, the first one and this second one. So once again, a meeting started, that's going to tell us to increment our count. So now we're going to say 2 meetings are once again going on. And again, we're going to repeat the same process. The next point is at 20. This happens to be an end time. So that means a meeting is ending, right? We don't technically even know, is it this meeting that's ending or is it this meeting that's ending? It doesn't really matter to us. All we know is that after this point, only 1 meeting is going to be going on at any particular time, and it's going to be this one. So we're going to take our count of meetings going on, decrement it, and now it's going to be 1. And last but not least, we're going to go to the last point in our grid, and it's also a end time. Obviously, the last point is always going to be a end time for a meeting. So that means another meeting is stopping. After that point, there's only going to be 0 meetings going on. So therefore, we can take our count, decrement it all the way down to 0. Now we notice that what was the max value that count happened to be? Well, the max it ever reached was 2. So therefore, we're going to return 2 as our result. 2 meeting rooms is enough to contain all of these meetings. So let me show you quickly how we're actually going to be sorting these points and how we're going to be able to iterate through each point in order, regardless of if it's a start time for a meeting or if it's an end time for a meeting. So I'm going to slightly change the example in this case. So just by looking at the picture, what do you think the meeting rooms number would be for this problem? Well, you see over here, there's going to be 1 meeting going on. Here, there's going to be 2 meetings. Here, there's going to be 2 meetings. Here, there's going to be 1 meeting. But look at this point at point time equals 10. Clearly, there's 3 meetings going on at this time, or at least 3 meetings have a 10 value included in their time interval. Does that mean that there's going to be 3 meetings going on? Well, technically, the way this problem is defined, this meeting would end before this meeting started. What I'm saying is these 2 meetings are non-overlapping. So when we are going through this point, if we ever have a tie, meaning if we ever have 2 points with the exact same value, what we're going to do is we're always going to iterate through the end meeting time before we iterate through the start meeting time, right? Notice how this is a end time, this is a start time. We're always going to pick this one if we ever get a tie like this. So we're actually going to have 2 input arrays. We're not just going to sort every meeting based on the start time. What I'm going to do is I'm going to put all start times in a separate array. So 0, 5, and 10 are all going to go in a separate array. These are all the start times for any meeting, right? This way we have them in sorted order and we know, okay, these are the ones that are start times. We can differentiate between a start time and an end time. We're also going to put every end time in an array as well in sorted order. So we can see the first is 10, next 15, next 30. So now we're going to start this problem off with 2 pointers. We're going to have 1 pointer at the beginning of start and 1 pointer at the beginning of end. We're always between these 2, we're always going to pick the minimum value. So we are going to maintain a count, which tells us the number of meetings that are going on. And if the minimum between these 2 is the start time, what we're going to do is we're going to increment the count of meetings with the exact same value. What we're going to do is we're always going to iterate through the end meeting time before we iterate through the start meeting time, right? Notice how this is a end time, this is a start time. We're always going to pick this one if we ever get a tie like this. So we're actually going to have 2 input arrays. We're not just going to sort every meeting based on the start time. What I'm going to do is I'm going to put all start times in a separate array. So 0, 5, and 10 are all going to go in a separate array. These are all the start times for any meeting, right? This way we have them in sorted order and we know, okay, these are the ones that are start times. We can differentiate between a start time and an end time. We're also going to put every end time in an array as well in sorted order. So we can see the first is 10, next 15, next 30. So now we're going to start this problem off with 2 pointers. We're going to have 1 pointer at the beginning of start and 1 pointer at the beginning of end. We're always between these 2, we're always going to pick the minimum value. So we are going to maintain a count, which tells us the number of meetings that are going on. And if the minimum between these 2 is the start time, what we're going to do is we're going to increment the count of meetings going on and then shift our start pointer to the next one. And we can see that that's the case again, right? 5 is less than 10, therefore a meeting has to start before this meeting ends. So once again, we're going to shift our pointer over here and we're going to increment our count by 1. So the count is now going to be set to 2. And now we get to the edge case, right? We got a tie. So a meeting is ending and a meeting is starting. Remember, we are going to visit the end time if there's a tie first. So what we're going to say now is that, okay, a meeting has to end before this meeting starts. So we're going to shift our end pointer to the next one. If we iterate through an end value, that means the meeting just ended. Therefore, we're going to decrement our count by 1. So 2 is decremented by 1. It's going to be set to 1 now. Now, again, we're going to compare these two values, 10 and 15. Which one is smaller? The 10, right? So therefore, another meeting is starting. So we're going to increment our count by 1. So count is now going to be equal to 2. And now we don't even have any start times left. So technically at this point, we're just going to be iterating through the end time. So we're literally just going to be decrementing this. So we iterate through this, decrement this down to 1, iterate through this, decrement this down to 0. So technically, once we've gotten through all start times, we don't even have to iterate through the remaining portion of end times.
Got it. So that's how we can do it basically. So it's like the widget size less than 2. You return intervals dot size. Right. Actually, I don't need this. I need start. Basically, as soon as long as we have start meetings, that's when we'll traverse the arrays. So if start of I is less than end of j, you do an I plus 1, count plus 1. Otherwise, you do j plus 1, count minus 1, and this should work, right? Oh, okay. Yeah, it worked. Okay, that was a really intuitive solution actually. Let's keep a track of the solution. Second, this logic makes sense actually. This should work. Yeah, this is working actually. Not this should work, but yeah, this is working. This makes sense. Cool. Alright, that's it for today. Thanks for watching and have a good night. Bye bye.